Hello, everybody. Good morning, or afternoon, or evening, depending where you live. My name is Nico, and I'm gonna be your host for the next hour or so. I work at Golem as a product manager, and today I'm gonna I'm gonna teach you how you can do close simulation on your crowd entities within Golem. And at the same time, also moderating the chat box, there's Alex, also from Golem. So if at any point during that live session you're having any questions, just feel free to put that into the chat box, and after that session, we'll take some time to address some question and answers. We're just gonna let a couple of minutes for more people to join eventually. Let me remind you that so this is the 10th week in a row that we're doing those live sessions, and we'll keep doing those. So next week is going to be on Friday evening, so same time than now, and we're going to talk about how you can make your own locomotion system. So take some mocap animations and convert them to create a new locomotion. And the week after, I'm not yet sure what's on, so just keep an eye on our website to know more about this. Okay, let's get started. This is kind of what you're seeing right now. It's kind of what we try to achieve today. So you can see it's a couple of characters here with some complete clove simulation, interaction with the characters' legs, and also interactions with Collider. So you can see here the characters that cross that cube or that bar in the middle of the scene, but you can see the clothes is colliding with it, and it's sliding on it. So let's see how we can achieve that. So I'm gonna start with a real simple asset, and speak more about what's the close process here. Oh, wait a minute, I probably need to change here the joint size because I was using a different scale of character, so it's probably way too big. Here we go. So within Golem, there are two ways actually to do some cloth, and they are represented with those two behaviors. So there's one behavior which is called a cloth behavior, which is the legacy behavior. It's here. But we tend to advise people not to use it. It's only here for legacy if you happen to have an old scene that you'd like to be able to run. And maybe in some really specific case, maybe you can use that one. Else, we prefer people to use that one here, which is called the Apex Cloth behavior. And Apex is the NVIDIA technology which is able to simulate soft bodies such as clothes. One advantage of using NVIDIA here is that it's the same tech that we are using also to make the ragdolls and the physics simulation. So those two simulations can cohabitate with each other. So that's why we advise these customers to use that one instead of the previous one. And also it's more advanced technology, so it's run way faster than the enclosed system that if you've been using before. You already know that it doesn't scale really well if you're having 10, 20, hundreds of characters, where the GPU, the NVIDIA APX system is a bit easier to use. So cloth simulation means that we're going to make some simulation based on the geometry of characters. So rather than, within Golem, what we used to do is always control the skeletons and inject some postures, and what's being written within the cache is going to be some bone positions and orientation. Here, the clothes is going to be different. We're going to write some actual vertex deformations here. So that happens at the vertex level. And it also means that if you export a cache with characters which has some clothes on it, you have your posture still within the cache, which is what you had before, but you also have a geometry cache being stored into the Golem simulation cache. So keep in mind that your cache size will be a bit bigger because you're having, for every frame, for every character which has a close simulation, you'll have those vertex deformations here. As it is at the mesh level, the close informations need to be specified also at the close level. So let me show you how that character looks like right now. So I'm gonna use this is the character file I made for that character. It's pretty, you know, casual stuff here. You got the skeleton here, you got the geometry here, and you got the flag group down here at there. So it's a variation. So some characters may not have a flag, some characters will have a flag. And as soon as they do have a flag, they have both the stick and the close flag. And those meshes here, so that's the stick, that's just the close asset. Let me show you which one it is. So that's the stick and that's the close. As soon as you set up a mesh within the character file, you've got that option here, which is called close asset file, and that requires an APX file. So APX stands for Apex, which is the name of the NVIDIA technology to simulate the soft bodies. So here we need to specify those close information within an APX file. So how do we create that APX file? And there are actually two ways to create those, and I'm going to show you here the two ways. So the first way here, let's say you do a flag like this, or you do a close and that close is a flag, or maybe it's a cape, or maybe it's a really simple piece of close that you'd like to simulate. What we can use is the automatic Apex file creation. So the way it works here is when I set up my character, let's take a look at the skeleton. Let's expand this. Okay. So I'm having my right end bone here, and that right end bone, if I if I change the orientation of that right end bone, everything is constrained to it, so everything is skinned actually on it. So my flag here, it's skinned on it, and well, it's not exactly true, so yeah, forget about this. So anyway, when I move my right hand, it moves the flag. That's what you need to remind. And then I also have something called a flag bone. And that flag bone is like super small. It's just one bone, which is right below the right hand. So it's just a child to it with a 0 offset here. And that's just a bone to make the differentiations between the vertices. So let me maybe go into much more details here. So I'm just going to bring a tool which is called a Skin Wrangler. It's not a regular Maya tool here. It's something you can grab on the internet. It's been developed by Chris Evans. So yeah, just take a look on the GitHub if you want to know more. But that's just I just want to make my point about what's going on here in terms of skinning. So Skin Wrangler just allows you to select some vertices and see what they're skinned on. So what I did here is actually I started by selecting my two bones there. And I used the Maya default skinning options within the rigging panel. So here within skin, I just selected my two bones, selected my flag, go with bind skin, and didn't change the different options. But then I used the Skin Wrangler to change my skinning weight. So let's go F9 here. Let's select maybe some vertices of on my flag. So what I did then next was to select here all those vertices here, almost all those guys there, and all those guys there, I skinned them. So when I first did that, so they were skinned off on the right end and off on the flag. So I just remove the right hand influence, and here I skinned them on that bone, which is called flag. So all those vertices, which means almost all of them except the border, which is here, is skinned on the separate bone, which is called flag. And that separate bone is just a child of the right end. And all those other bones, other vertices here, I skinned them to a bone called right end. So that flag here is divided into all those vertices except the one I selected. They're skinned on flag. All the rest, they're skinned on right end. So what's the point of doing so? The point of doing so is that if some vertices are skinned to some specific bones, we can tell the Golem system that those will be close simulated. So it means that all those vertices except the one I selected will be part of the closed simulation, where all the one which are selected right now, they belong to another bone here. So it means that they will not be simulated as a clove. So they will act as an anchor. So they will attach the other part of the mesh to that stick. So when the end moves, the rest moves, and the simulation happens. Okay, let's see how that actually works. So to be able to use the automatic apex creation, what I need to do is to create a simulation and to actually use one of the behavior I just showed you. So I'm going to bring that character file here, which is casual man there. I'm going to populate, sorry, that tool here will pop some errors during the whole duration. Every time I'm going to do something, that's because it hasn't been updated for a while. But as soon as I open it, now it just exists, and that will pop some errors all the time. I'm gonna make a quick grid, 5. So a 5x1 grid here. There. Put some distance between my characters. Well, I only need one, but I'm just getting used to making multiple characters there. I'm gonna use a 270 degrees unit. I'm gonna check what's going on here in my scene. So it's characters without a flag, but I do have a rendering type here, which allows me to put some flags here. Okay, so now I'm having my flag, and if I play the simulation, nothing happens, which is expected, right? Then I need to bring my apex behavior. And that apex behavior asks me, so what's the mesh I would like to simulate as a cloth? So it's the cloth flag mesh. So here there was a list of all the meshes which are listed within the character file. And you can see you got that panel here, which is called automatic apex creation. And you got a couple of parameters. So the first parameter we'd like to play with is what's the close vertices bone list. So what are the bones within the character that we will use, and we're gonna look at all the vertices of the meshes which are listed here, which are skinned to those bones, and we'll apply those physics attributes to them and let them do a close simulation. So the actual bone I want to read it from is the bone name flag. Remember, that's the bone I defined here, which was right in the end, on which I skinned all those bones there. And something that I really need to do also is the physics engine doesn't like the character maker to have some characters being loaded into it, because it makes some collisions with the locator. So make sure that you're always close of all your tabs here. And there's other options such as what's the friction, what's the gravity scale, what's the damping. So we'll probably change those later, but now if we play the simulation, what's going on here is that your clothes get assigned, all the vertices which are here, they get assigned with those physics properties, which means that if I increase probably the damping, I will have more damping on my clothes, where if I slow it down to, let's say, 0.05, I'll have more inertia. Here we go. So I'm not really good with clove simulation. Well, I understand those parameters, but it requires some artistic skills here that I totally don't have to set those properly. But still, you can, set up those here and get a proper simulation with that. You can also specify what are going to be the colliders in terms of rigid bodies for your characters. So if you want that flag to collide maybe with the leg or maybe with other parts of the body, this is where you'll be able to input those. And when you're happy with those, you can check that box here. And if you check that box and you play the simulation at least once, here and there, what's going to happen is, let's rewind the sim. What's going to happen is that now your close mesh that you had before, or maybe I need to save it first. or maybe it's written, it's supposed to, wait, it's supposed to write it next to the character file. So let's check. Save file. Okay, yes, but that's because I forgot to close that tab here. That APX I'll need to figure maybe within the documentation where it is, but when you press that button here, save APX file, that's making a copy of an APX version that you can actually load within your character file. Maybe check out the documentation, or maybe I check that later to see exactly where it's been written. But that's just a way to bake, well, not bake, but create an APX file that you can use into a different scene, and you don't have to set up all those attributes again. You may have noticed, by the way, that the character, the flags, they're colliding with the ground. So if you'd like, to take the ground into account, what you can do is bring a box. So remember, don't make like just a one plane, because plane doesn't have any white, and physically an object which doesn't have any white doesn't exist. Even a piece of paper has some thin, it's quite thin, but it exists. There's a white on it. So what you do is probably just create a box here. So my h is going to be 1, and I'm going to put that at minus 0.5 to put it at the origin. I can create a rigid body out of this, so create a collider, selecting my box here, making it as a collider. So now we can see those white lines, and finally it has created a crowd rigid body object here, my collider, which I can assign to my behavior to say, okay, this is going to be a rigid body I want my flags to interact with. And now you can see that there's some Z collisions depth here, but you can see that now the two objects collide with each other. So that's just a visualization issue here, that it's kind of flickering. That's because they are at the same height. So Maya has some troubles to figure what's the right order to draw those meshes. By the way, if that, as I just said, don't use a plane to make a ground, that applies as well whenever you do a close. So here, that piece here is actually made of two surface. So it's I think it's a tiny box here. It's not a plane, it's a tiny box. So it has a width as well. And it's really important that all objects have some width. So that's for the automatic Apex creation. So that really makes sense if you got, something which you just need to specify which vertex are going to be close, which vertex are not going to be close, and the rest of the close is going to be pretty similar in terms of behavior. Like, means like all the vertices here, they have the same behavior for the simulation. You don't have an individual control on each vertex to specify different properties here. So let's say you need to have this control because you need to do something more advanced. What's the way to tackle that? So let me maybe open another character here, because the flag is not going to be convenient. I'm going to go for that one here. So that's the character that I was using during the beginning of that demo. And that character has a trench coat. So now I want to create an APX file which will contain all the information for my physics and close simulation later. The way I do that, so yeah, just a quick word here. I'm going to use a plugin, which is an external plugin. So here I installed the NVIDIA Physics plugin. I'm running Maya 2008, and the thing is, that plugin here only exists until 2018. So NVIDIA right now, they don't have a version for 19 and 20. Also it's only working for Windows, so there's no Linux version right now, but it's work in progress. So soon, ASAP, I hope, there's going to be versions for 2019, 2020, and probably on Linux as well, which we are discussing right now. So stay tuned if you want to know more about that. But we're actually working on that. So that plugin here, just load a new shelf, and that's the physics shelf. And as soon as I select a geometry here, you can see you got that close button here. So now you're gonna say that that piece of mesh is gonna turn into a close. So an NVIDIA close system. So there's a new node here in your scene, and that new node allows you now to paint some specific values. So I can bring the paint tool here, and there's various attributes I can paint, but probably the most important attribute I want to paint is the max distance. So max distance means that what's the maximum distance you're allowing on the vertex compared to its skinned position. So here those bones are skinned probably to the leg, the leg will move, but if there's a close simulation, what's the distance you're allowing between the skinned position, so with the actual leg deformation, and the close simulation. So it's kind of a latch that you can paint on it. You can visualize this with lines. So here, visualization mode is going to be lines. In the value 1, well, you can see 1 is going to be 1 grid unit here, so it's not enough. It's probably something like 10 I want to paint on. And that trench coat here, it's going to be more or less skinned and rigid from the upper part, but the bottom part there, I want to like influence it. So I'm going to paint. So what as well, I'm not a character effects artist here, but well, I can paint, right? So I'm just gonna paint what I figure will be good. Sometimes you can make maybe some gradient saying, okay, that's gonna be 5 here. So you can override those and put some gray, probably load the map as well. And the 10 is gonna be there as well. So yeah, you can probably do way better than me, but that's the whole idea here. And remember what I was saying earlier, here I'm painting the external part, but there's also an internal part, because that geo here is not one, is just not one plane. It's a full volume here, really thin one, but it has some white here. So I can paint those, try not to forget any vertex. And one really nice thing is that that physics plugin allows you to test your closed configuration right away. So I'm gonna turn off the display here and move out from the paint tool. And here, when you use their play simulation button, it takes just a while for everything to initialize, but now you're having your clothes being simulated. So the character is not really moving, so it's not really interesting. Probably let's add a quick keyframe on the root bone. So let's rewind to bring back the initial state of the character. So here I rewinded it here. Let's select the root bone, add a keyframe from the frame 10, well 5, and the frame 15. I'm gonna move the character. Well, probably it's better to have an actual animation here, but I'm not an animator neither, so I won't be really good at that. So now I've got my keyframe, and if you want to see what's going on in terms of physics, you need to run it from the NVIDIA tool here. So now I'm moving that character, and you can see it's ending up with collisions. So let's fix those. So it's ending up with collisions because I haven't defined anything in terms of collisions with that character. So let's rewind it back. And what I want to do is define some collision volumes for that character. So I'm gonna select the root bone here, and I'm gonna ask to create a kinematic ragdoll. So it's really similar to what you've been doing within Golaem the rest of the time, where you're gonna assign a shape to every single bone. So keep in mind that it's just a limitation from the NVIDIA system, but each bone, each mesh, each cloth can collide with maximum 32 bones. So it's written into the documentation, but just a quick word about that. So it means that here the characters has fingers and all those stuff, and probably those fingers won't collide with the lower part of the trench coat. So probably we need to remove those. All's not required, just remove it. And also, if you decide that maybe your leg is going to be approximated with a capsule, Just keep in mind that it will count as 2 bones, because internally within the NVIDIA physics engine, a capsule is going to be 2 bones, it's going to be 2 spheres. So as soon as you create the ragdoll system, you ended up with a ragdoll node here, ragdoll locator, with which you got all the bones of your characters, and it's usually good practice to remove the one which are not required. So forearm, here I'm selecting everything which is not required and removing them from the list. So remove this, calf, knee, the neck, probably don't need those as well. I'm gonna keep the thigh and remove the rest. So now I'm having 6 bone here, the calf, knee, and thigh. And as soon as I got that calf here, I can set up what's gonna be the type. Is it gonna be a capsule, cylinder, or really up to me here? And if it's a capsule, what's the radius and what's the 8 of it? So I don't really know. Let's put something like this. Let's do something similar for the other side. So probably we'll have to copy the values. Would be better to copy the values to have something kind of symmetrical. The knee here. Well, they kind of, well, which one is what's what? Let me take a look. So we got the calf, which is there, and we got the knee, which is at the same position, and what's below it? Oh, calf, foot. Okay, the knee probably just here, just for the skinning, so probably not required there. So let me remove those, and just keep maybe the tight here. Maybe I should have added the feet instead. Anyway, well, you get the idea, right? You're kind of making your character here in terms of rigid body, and that will act as a collider avoidance, as collider for the physics system, which means that now if you do your physics your close simulation with all that deformation that I just applied, now you don't have that collision anymore. So I'm not here, probably there are some vertices that I haven't painted correctly, but more or less it's the idea here. So you spend some time here. You also spend some time to specify the rest of the properties, the physics properties, the bending, resistance, the compressions, also all those same attributes that you also having from the automatic apex creation. Within the paint tool, you can also paint latch distance, max distance, latch to nearest, backstop offset, backstop radius. So those are documented into the NVIDIA documentation. So take a look if you want to know more exactly about those. Once again, I'm not really a character FX artist. I can understand those parameters, but I don't have data skills to set them properly here. And when you're happy with the result, so you need to bring that APX file into Golaem, right? So when you're happy with the result, you select your mesh here, and you're going to export selection. And that export selection within Maya, as soon as you got the physics plugin being loaded, you ended up with a physics file of type here. So you're going to say that you want to export a physics asset. If you've been defining a collision rig that I just had, you want to include that collision rig. You want to make sure that the output unit is going to be proper. Use long name, export, validate scene, export fast to new folder, whatever. You just provide a name here, and when you're going to press export selection, it's going to create an APX file for your character, which brings us to almost the end of the live session. So if I go back into my penclose scene here, so it brings you to that character here, and if we take a look at that character, that trench coat mesh, which is there. Now let's expand this. Now that one here as an APX file, which I've been exporting from another session here. So I just assigned that APX file, and now I can go within my behavior. So let me close this because the system will not like that the tab is opened at the same time. So now within my behavior here, I can specify that the mesh I want to animate is going to be the trench coat, and there's nothing required here in the automatic apex creation because that APX file already exists. So it's just a matter of saying which is the mesh I want to animate and what's going to be the rigid bodies into my scene I want to collide with. And notice that that tight and that calf stuff, so the collision meshes which we've been specifying into the physics system, they're being taken into account by Golem. So when you run your simulation, apply some postures, those colliders will move and will interact with the clothes, which means that when you play the sim, you get that result there. And let me end up with just one detail, is that this is stored as a behavior, which means that you can control which who's get a clothes being applied and who doesn't. And people who don't have a clothes applied, they just follow the skinning rule. So let's say we'll just want maybe half of the character, or maybe it's probably like a camera distance you want to use, right? But let's say like 50% of my character will have clothes, the rest won't have a clothes. Now you can control with behaviors when that close happens and when it doesn't happen. So you can see those guys here, they're entirely green, so that means that there's no close simulation. And those guys who got the white stuff, they're having a close simulation being applied to them. And it also means that you can stop this at any time, right? So maybe you want to play that behavior only for 100 frames. You can just change the stopping trigger, and as soon as you stop that behavior, it will go back into playing skinning. So now it's playing for 100 of frames, and after 100 of frames, the behavior just stop, and your clothes go back to the skinning mode. So if your characters are really far from camera, or maybe they're not visible anymore from camera, it's a good idea not to use the close system. And also I tend to disable that close behavior as long as I can. So I usually like make my simulation proper, do all my behaviors with the avoidance and all the stuff I need. And last minute, when I really need to render that, I just turn that in. Let me turn that in, and I just let me bring back the shaders, and I'm gonna just save this. And last minute, what I do is just export within a cache. So I just enable the close really at the end, because it's gonna take a couple of resources to actually compute those closes, and I don't want to spend too much time in that computation while I don't need it. And when it's exported, you can see the result of that. You still have the simulation result, so we still need to go to frame 0 to remove that. And you can see that now that close stuff appears in cache replay. You can manipulate your characters with layout, move them elsewhere, and you got also that close being followed, but no more simulation, right? And just to make my point about rendering here, I'm gonna render that, and we're gonna end up with this. So if you got questions, now will be a good time. Yeah, sure, I don't have the shaders within the scene, which is expected, but now when we're gonna render, it's gonna place the bounding box, and it's gonna generate the close cache on the fly. So you get that nice close simulation here being applied onto your characters at rendering time as well. Okay, let's take a look if there are some questions. Hey everybody. So first questions is, will this work on non-NVIDIA systems? Yes, totally. Actually here we are not even using the GPU acceleration. NVIDIA tech is mostly focused on using the NVIDIA hardware. But as we're having customers who are using Golem in batch mode, so they're running simulation in batch mode, all the computation you can see within the simulation, there only happens on CPU, so we don't care at all about the GPU graphics card that you're using. So it can be anything else than NVIDIA that will work exactly the same. Just the graphics card are just going to be used for the display, and that's just for displaying characters. So no simulation will happen on the graphics card. So yeah, if you're using non-NVIDIA hardware, that's all good. How would one go about adding external forces to apex close, like wind or turbulence? So turbulence, not really easy to do, but not really easy to do with the current setup, I will say. but the wind is actually something which is part of the apex closed behavior. So you got something called the wind velocity and the wind noise. So let's say we want to produce some wind in the minus x-axis. I'm not sure what the adaptation is. Probably we'll have to check the documentation here. But yeah, if you produce some noise, some wind, well, it's probably not high enough, right? Let's change the order of magnitude of this. So okay, there's some wind, but I can see it's kind of noisy. The wind is not like a big wind going up. So let me check what's the adaptation there. Okay, not really convenient. Okay, I'll have to check, but those parameters are supposed to simulate some wind. Oh, sorry, that's on the y-axis. That's probably... So yeah, there's no sense having it on the y-axis. That was on the minus x-axis. I wanted to apply that. So let's check how it goes when, oops, when we apply that on the minus x-axis. Okay, now we're having some... No, so here you can see now we're having some wind going into that direction here, which is only influencing the bottom part of that trench coat, which is the one we've been painting weight on. And probably if I maybe increase the weight on this, even add a more bigger order of magnitude, yeah, now you can see you're having a full complete wind being applied onto your character. Yeah, sorry, I just messed up with the axis here. The y-axis is going to be up-down, so that's why we couldn't see most of it. So I'm not sure what's the adaptation. Well, there's a mistake here, probably adaptation. So adaptation, okay, I can see that Alex went into the documentation to check. Thank you. Rates adapt to the... We're back. So if we put that to 0, probably there's no wind at all. Okay, that's a kind of a ratio of how much the clothes get assigned to that wind system. So for a specific turbulence, nothing is really made for that. But as we got some wind, probably that's not a big deal, I guess, to add something like this. Let me go up a bit. So okay, there are the wind settings on the behavior. That's correct. Yeah, sorry. Sorry. It looks like my computer froze for just a minute. So that's why you probably lost the sound for just a couple of seconds. Physics is NVIDIA only, though, right? I kind of answered that question. Physics as well is physics is running on CPU. Sure, it's developed by NVIDIA, but it's not only running on NVIDIA graphics card. So you can use any CPU, or you can use any hardware. To be honest, you can even use you can simulate this on Linux, having an ATI card, and that will work. So it's developed by NVIDIA, but it's not limited to NVIDIA hardware. Nor the physics or neither the apex, so close or rigid bodies. You can use any hardware to run them. So there's a question also. So there's a precision from Eduardo from its question. So for more precision on the close simulation, should I increase the substeps on the Golaem manager, or it happens somewhere else, like on the nucleus for the legacy? So the close, as they are handled by the physics proxy here, what you need to change, or anything you need to change here, it could be the gravity, the interaction, the crowd rigid body. It happens within the physics locator. So the substeps that we're having within the manager, therefore the simulation, and therefore the motion behaviors, therefore the navigations and that kind of stuff. But whenever you're having something which is related to physics, and that includes also the cloth. Oops, I already had a physics locator. So as soon as you're having some closed behavior, you end up with that physics locator, which is dealing with all the physics properties of that system. So this is where you're going to specify the gravity, this is where you're going to specify the friction with the default ground, and this is also where you're going to specify the actual physics substeps. So this is how many substeps the physics engine will use to solve that closed system. So yeah, whenever you need to change something which is related to physics, this is going to happen here. There's a question from Yuri about what about Maya enclose. We do have a tutorial if you want to jump into this. I'm not really willing to actually speak about that behavior. As I said at the beginning of that session, that enclosed behavior is not practical at all. It's just here for legacy because if you want to open some old scenes, that behavior still exists. But the setup is pretty easy. You just specify what's going to be your geometry. So you need to have within your scene an actual character with the enclosed system on it. So you need to import that within your scene. You connect your close your Maya close stuff here. You connect your actual colliders in it, and you run the simulation. But it's really unstable. It's not really interactive. It ends up just writing some vertex deformation within the cache, but really it's not practical. Really not practical at all. I'll let you try if you want. If you just check for enclosed simulation Golem, you figure it with the tutorial. But yeah, we usually advise people not to use it. You can do pretty nice stuff using the Apex close. Just to make my word here, let me show you. We got a really nice example here. So that's from the people at RodeoFX. They made. So if you check on the website, you can find the testimonial about RodeoFX. They made a use case about what they did on that movie. So RodeoFX is a Montreal studio here. They worked on the Nutcracker, which was a Disney movie released maybe 1 or 2 years ago. And like every single character you can see here, bipedal characters, they're having, all of them, they're having a piece of at least one piece of clothes. Maybe some of them have multiple pieces of clothes, which have been configured within the NVIDIA physics system, and you're having hundreds of characters here, and it's a full shot there. And if you read the story, there every single character that you can see here, even some characters which are really unique, every single characters was bring into Golaem, sometimes with some specific keyframe animation, some vignette animation, just because the physics system was so fast and so efficient. So all those characters which are really unique in terms of behaviors, they're using the physics system. They were using the physics system to simulate all their clothes. And you got a piece of breakdown where you can see the setup in terms of clothes. So if we just move forward here, so that's the assets there. Okay, all good. Oops, maybe that was before. Okay, here it is. So that's the actual character. So you can see all those skirts here. They're all the result of the physics simulation, and all those you can see that trench coat. You can see the skirt here on the girls. Piece of physics simulation. Well, Apex simulation all the way. We believe that if RodeoFX is able to do some top-notch shots for Disney movies, we believe that the Apex close is pretty good enough for most requirements. If it don't, just let us know, and we'll try helping you figuring what's wrong here. Okay. What else do we have? Okay. Just if you're having a couple of questions, last questions, that will be the good time for that. In the meantime, let me remind you that next week we're going to speak about how you can make a complete locomotion system from some mocap. So we're going to show you how you convert animations and what we tend to look for when we convert animations. If you got suggestions about some specific topics you would like us to include into our next sessions, let us know. Just send us an email or put a comment into the comment section of that video. And you can grab, as always, you can grab the software on the website for free, so you can try it and try for yourself what I've just shown you. If you're having some cool results, feel free to send those to us, and we'll be happy to maybe share it with the rest of the community. And let me check if there are more questions. There aren't. And if you haven't subscribed to the channel, do so you know about when are going to be the next live session. So next live session is going to be probably on Friday, and the one in 2 weeks probably on Thursday. But I'm not sure if the topic has been decided. So feel free if you need us to address a specific topic. You guys stay safe. Thanks for joining us. So that was our 10th week live session in a row. So we've been doing this for 10 weeks now. So hope you enjoy that. I've been enjoying that quite a lot. So you guys stay safe and take care. And see you next week.